when studying motion, one thing that's very useful for us to be able to do is draw and read position time graphs. So position time graph, position is on the y-axis over here. So I'll write that, and we write that as x. And then time is on the y-axis over here. So what you're going to do is we're basically going to look at a few different examples of position time graphs and what they mean. So the most basic position time graph is just a horizontal line straight across the graph. So reading this, the position here, position at the first second is, we can call this 5, right? 5 meters away from wherever your origin is. So right here, it's 5 meters at time equals 1. A little bit further on, it's still 5 meters. A little bit further on, it's still 5 meters. Still 5 meters. So this position time graph is somebody who is not moving at all. So my position time graph, if I'm just standing here, would look like that. If you're standing at the origin, then your line is going to be directly on this axis here, and it's going to be horizontal and x equals 0. Right? The x equals 0 line and the t equals 0 line. So that one is kind of trivial, so let's look at a more interesting graph. So we could have a graph that looks like this. And is a straight line with a positive slope. So to kind of remind you what that means, slope is rise over run, right? So the rise is positive, the run is positive. You have a positive over positive, so this is a positive slope. What this says is that my position is increasing as time progresses. So that means that if my origin is behind me, I walk at one constant speed away from my origin, right? Because in each second, my position changes by the same amount. So I can't be speeding up or slowing down or anything like that. So there's none of that. I could also have something that looks like this. Now, this has a negative slope, which means I have a negative velocity. What does it mean to have a negative velocity? Remember that velocity is speed with a direction tacked onto it, right? So if I have a negative velocity, it means that I'm still traveling at one constant speed, but it means that I'm moving in a negative direction. You can see I start up here and I'm moving towards my origin. That'd be like if my origin is over there, and I said that was the positive direction, so I walked this way, and I got the top graph. If I turned around and then walked the other way, I get the bottom graph, because now I'm traveling in the direction that I defined as negative. So these two graphs are most straightforward, still no acceleration, we're not changing our velocity at all, and you can really see that for position time graphs, the slope represents your velocity. So I'm going to write that over here. I'll write it in. So for position time graphs, slope equals velocity. Alright. And that's going to become in very handy as we continue looking at some of these graphs. So, let's look at a graph where you are speeding up or slowing down or things like that. These graphs are going to be a little less intuitive, but we're going to gain an intuition for them. So, the first graph, this is position and this is time. Let's say I want a graph to represent my motion. If I start slowly and then I start speeding up near the end. And I'm moving in the positive direction, right? I'm still moving in the positive direction. I'm just going slow and then fast. So if I move in the positive direction, my slope is going to be positive. However, I start off slow. So we're going to have a small slope, right? But then I speed up. So my slope, my velocity is increasing, which means my position should change faster. So I start off here, and my position needs to change faster, so I get that. So this is where our velocity, which I'm going to be writing as v, is greater than 0, and our acceleration, which I'll be writing as a, is also greater than 0. So if we have positive acceleration and positive velocity, that means that my velocity points in the positive direction, and I'm also accelerating in the direction that my velocity is going. So velocity, acceleration, I go fast, or I speed up. Do not confuse positive acceleration with speeding up, because what we're going to see is that it doesn't always mean that. If velocity and acceleration have the same sign, which here is positive and positive, then that means we're going to speed up. However, we're going to see they can also be negative and negative, and you'll speed up. And if they're opposite signs, then you're going to slow down. So let's say I want to graph, let's say I want to graph, I'm going to go in the positive direction still, but this time I start off really fast and then I slow down. What is that going to look like? Well, draw my axes here, position time. I start off really fast and then I slow down. My velocity is still positive, so like this one I need to have a positive increasing slope, right? So this means that I'm going to start here. I start off fast, so my position is changing very quickly. But as I progress, I begin to slow down, so my velocity decreases. And I get something that looks like this. So you can see that, remember, the slope is the velocity. So here we have a positive slope, and it's very small, so we're not going very fast. But as we continue, it gets greater, and it becomes faster. Here, it slows down, right? Our slope becomes less and less and less, and it slows down. So here, our velocity is still greater than 0, and it's positive, but our acceleration is less than 0. It's negative. Here what's happening is my velocity is this way, but my acceleration is that way. So I want to go this way, but my acceleration is pulling me back, and eventually I slow down and stop. And in this case, we can see I am slowing down. So we can see there's still two more graphs that we can look at based on the combination of signs. So x and t, x and t. So suppose I want to look at a graph where I flip the direction of velocity. So let's say I'm traveling in a negative direction, so I'm going to go this way. So let's say I do the same thing as here. I want to speed up. So I start off slow, and then I go faster and faster and faster. So in this case, my slope needs to be negative. I start off not at the origin, I start off a distance away. So I start there, my slope needs to be negative, and then what happens? I speed up, right? I'm going faster and faster. So I start off slow, so my slope shouldn't be that great, but as I run, I start speeding up, and my velocity becomes greater and greater and greater, and should look like that. So it's essentially this flipped like that. So we take that, we did a reflection across the t-axis, and it looks like this. So here, our velocity is less than 0, so it's negative. Our acceleration is also less than 0, which is negative, and we speed up. And this is why I warned you not to associate positive acceleration with speeding up. Because here, which direction is my velocity in? Negative. Which direction is my acceleration in? Negative. So negative and negative, I'm going to go this way, and I'm going to go faster and faster and faster because my acceleration is pointing the same direction, and I speed up. So that's why you can speed up even with a negative acceleration. Colloquially, you can also say deceleration. So this leaves only one left, which is where I start over here, and I start off really fast and then I slow down. So in this case, I'm starting off really fast, so I don't start at the origin, I start a distance away. I start off fast, so my slope should be very large, very steep. And as I continue, I slow down, so my slope becomes less and less steep. I should get that. So here, my velocity is still less than 0. And remember that your speed is not less than 0. Speed, the magnitude of velocity, is how fast you're going without the direction attached. I'm clearly not going 0 or less than 0. That doesn't even make sense. Velocity is the direction also. And because we have that direction associated with it, I have a positive speed with a negative direction, so I have a negative velocity. Similarly, I have a negative acceleration because I'm accelerating in the same direction. So, positive acceleration because I'm slowing down here, right? Acceleration is greater than 0. So this is minus, plus. So we start here, I'm moving this way, but I slow down and stop. So, here we have a positive acceleration, and we're slowing down. So again, this is somewhat counterintuitive, but what you really need to keep in mind is whether you're speeding up or slowing down is a function of how the slope changes, right? Because if velocity is the slope, speed is just the steepness of the slope regardless of sign. So here, not steep, later on it is steep, so we speed up. Here, steep to not steep, so we slow down. Here, steep to not steep, we slow down. Not steep to steep, we speed up. So, the thing to keep in mind for position time graphs is, I'll write this over here actually. So slope equals velocity. If you increase steepness, that looks very messy. If you increase your steepness, it means that you're going to be speeding up. Increase steepness, increase speed. Okay? So if velocity and acceleration have the same sign, then that means that you're going to speed up. Your speed will increase, and if they have opposite signs, then you slow down. Your speed goes down. The reason for that is because if I have a velocity in one direction and I'm accelerating the opposite direction, then that means the only thing I can do is slow down before I start moving in that direction. So this is pretty much all you need to know for position time graphs that we're going to be doing. So now we're going to move to velocity time graphs. Now velocity time graphs are very similar to position time graphs, except instead of position, you're graphing velocity. So we're just going to look at a few of those. So, here, I'm going to say this is velocity and this is time. So, let me actually go down into negatives. So, if I have a velocity that looks like, let's say, just this, what does this mean? Well, for position time graphs, this meant you were standing still, right? For velocity time graphs, it means your velocity is staying exactly the same as you progress through time. So this means that I'm moving like this. My velocity is not changing, I'm moving at a constant rate. Right? But up here also, what's the sign? It's positive. So it means that I'm moving in the positive direction at a constant rate. If my velocity was down here, then this would be me moving in a negative direction at a constant rate. So I would start over here, and I'd walk at a constant speed towards the negative direction. Velocities can also cross from negative into positive, or from positive into negative. Right? We could have something like this. So if we have something like this, my velocity is decreasing the entire time, right? This is where you have some acceleration. So just like the slope of a position time graph was velocity, the slope for velocity time graphs slope equals acceleration. And that means the steepness is the magnitude of the acceleration, and the sign of the slope is the direction of the acceleration. So here we have a negative acceleration, right? We have a negative slope, negative acceleration. We start with a positive velocity. So if I have a positive velocity, I'm moving in the positive direction, but I eventually switch to negative velocity, right? And I mean, my magnitude of my speed is decreasing. So I start off fast, I slow, stop. When I stop, I'm at the origin. My velocity is equal to 0. And then I start moving backwards, and I'm increasing my speed backwards. Okay? Because what's happening is even though my velocity is becoming more and more negative, the speed, which is a magnitude, the number, the absolute value of the velocity, is increasing, right? Here it's -1, here it's -2, -3, and so on. So that's what that graph represents. You could also have a graph that looks like this, where I start off moving in the negative direction and then switch to positive, right? And this means my acceleration point's in the positive direction. So my velocity here starts off negative, so velocity is negative. Acceleration, positive slope, so I have positive acceleration. So I go like this, slow down, stop, and then I go faster and faster in the opposite direction. So that's what that graph means. And that is pretty much all you're going to need to know for velocity time graphs for now. You can also figure out the position, how much position was covered from a velocity time graph, but that won't be covered in this video. So that is what you need for position time and what you need for velocity time. Overall, you're going to be asked, it's a useful skill to be able to read them and recreate them given a certain physical situation.